this is section 11-1. I'll change colors because we don't like to write in red. So all these things that we just looked at, 2, 4, 6, 8, 2, 4, 6, 8. What comes next? 2, what comes after 2, 4?
15.
No.
10, 12.
No. Who do we appreciate?
36.
2, 4, 6, 8. Who do we appreciate, right?
10.
Not 10. No. Who do we appreciate comes next?
Oh.
Oh, no, I'm just kidding. Okay. 2, 4, 6, 8, 10, 12. Okay. 1, 2, 4, 8, 16. Okay. 2, 6, what came next? 12, 20, whoops, 20, 30, etc. All of these things have a name. These are called sequences. Okay. And this is section 11-1, and this is kind of an introduction to what a sequence is, okay? And then we'll talk one day about, after this is kind of a general overview of sequences, and then we'll talk one day about arithmetic sequences, and then we'll talk one day about geometric sequences, and then we're done for the semester. So there's really only 3 more things we're going to talk about, okay? So a sequence is, okay, you might want to write this down, is an ordered, I don't have much voice to it.
Yeah, you can make it fun.
An ordered list of numbers. I have a microphone of numbers. Take some notes there, Calvin. Okay, so sometimes we will write a function rule, okay, like this. So a sub n, okay, means gives you a rule for the sequence. So a sub n equals 5n 5n plus 1 is the same as writing a of n is equal to 5n plus 1, okay? Where when we're talking about sequences, the terms, n is the number of the term, okay? So n is the number of the term, okay? So for instance, up here, the first term is 2, the second term is 4, the third term is 6, and so on. So 4th, 5th, 6th term. So n is the number of the term. So n equals 1, n equals 2. What is a? So sometimes what they do is they write a of a sub 5 for this particular sequence, okay, is going to be equal to 5 times 5 plus 1, which is what? Which is what? 26. So if I had a particular sequence that looked like this, and they asked me to write the first 5 terms, my first term, right, first term would be 5 times 1 plus 1, right? First, for this particular sequence, right, would be 5 times 1 plus 1. The second term would be 5 times what? 2 plus 1. The third term would be 5 times 3 plus 1. 5 times 4 plus 1. And the fifth term would be, so third, fourth, fifth, 5 times 5 plus 1. So this sequence, if I were going to write it out, is going to look like 6, 11, 16, 21, and 26. Questions about that? What a sub n is? All right. So that's what a sub n is. Finally, so sometimes, so this one that I just did, it's called an arithmetic sequence. We'll learn more about that tomorrow. An arithmetic sequence is one that the same amount each time. So this one is going up by 5 each time, but there's other tons of different types of sequences. Like this one, is this an arithmetic sequence up here? Yes, because this one's changing by the same amount each time. This one is not, because it's not changing by the same amount each time. It's a different kind of sequence, as is this one, okay? So depending, like you could have sequences, but they're not all generated in the same. Okay, time to stop doing this and pay attention to what's going on in math class. Can you please put your phone away, Calvin? Okay. So what if I said, find the first 4 terms, find the first 4 terms for a sub n is equal to -1 to the n times n squared. So this is kind of a different type of sequence. What would be the first term? That's right. Would it be -1? Yeah, it would be. So a sub 1, right, is going to be equal to -1 raised to the first power times -1 squared. -1 to the first power is -1. What's -1 squared? +1. So what do I get out? -1. Okay? A sub 2 is going to be -1 to the what power? Whoops, I wrote 2, I meant 1, right? Wait a minute. Oh, no, that's 2. Let me fix that for our home viewers. Good. A sub 2, -1 to the what power? 2 power, right? Because this is n, times 2 to the second power, which is what? What would I get if I multiplied that out? What would I get out? +4, okay? A sub 3 is equal to -1 to the 3 power times 3 to the 2 power, which is going to give me what? What's 3 to the 2 power? 9 times -1 to the 3rd power. What's -1 to the 3rd power? -1. What's 9 times -1? -9. Okay? A sub 4 is going to be -1 to the 4th power times 4 squared. What's that going to give me out? Hello? Oh, I wrote 6. Sorry. I was looking around. Who could tell me what a sub 5 is without having to actually plug it into the formula by looking at the pattern? What's a sub 5, Will? What's a sub 5, Calvin? You should pay attention. What's a sub 5, Mandy? It would be -25, okay? That's going to be -25. Notice, negative, positive, negative, positive, negative. This, putting a negative 1 in front and making it, and putting this as the number of the term has the effect of making it change signs back and forth and back and forth and back and forth. Okay? And here we're just squaring the number, right? So, whoops, no wonder you're all messed up. This should be a +1, right? This should not be a -1. That's why you're messed up. 1, 2, 3, 4, squared, 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 right? So they're just square numbers, except this has the effect of making them negative and positive, right? So this would be -1 to the 5th power, which is -1, right? Times 5 to the 2nd power, which is 25. And that's what I get. Yeah? Questions about that? What would 8 to the 9th power be, David? What would a sub 9 be? What would a sub 9 be? Sophie? Negative 81, right? Because the odd powers are always going to be negative, and the even ones are always going to be positive, and then you just square the 9. Very good. Okay. All right, so that's one particular type of sequence. So that's pretty easy. But not all of them look like that. So what if I had a sequence that looks like this, where I did have 2, 4, this number, 2. What if I had this sequence? 2, 4, 6, 8, 10, which is the one that we had, and I want a sub n is equal to something. So what if I were going backwards and I have a pattern and I want to know what the formula is? Anyone know what? So this is n equals 1, 2, 3, 4, 5. Okay? Adam.
Is it 2n?
It is. Okay? How'd you figure that out?
Well, the n term is going to be 1, 2, 3, 4, 5, and if you multiply the n term by 2, it's going to be
Right. So if you look at these terms, right? Here's 1, here's 2, here's 3, here's 4, here's 5. So this is the number of the term. So 5 times 2 is 10. 4 times 2 is 8. 3 times 2 is 6. 2 times 4 is 7. So if I have something that looks like that, God bless you, whoever just sneezed. The pattern here is, whoops, I need my tools. Where's my tools? Where's my colors? Where's my colors? Oh, there they are. Okay. So this is just going to be 2n. And if you have something like this, an arithmetic sequence, that 2n is how much that 2 comes from how much it's changing by. Okay? What if I had this one, like 3, 7, 11, 15, yeah. Who thinks they can figure out what a sub n is equal to? Go ahead, Quinn. And it wouldn't be n plus 4. It would have an n times 4 in it. Okay, so this is kind of tricky with these ones. Notice that it's changing by how much each time? It's changing by 4, right? So this is 4, this is 4, this is 4. So what that tells you is I have a 4 times n in my answer. Yes, sir?
It would be n times 4 minus 4.
N times 4.
Minus 4.
Did you just figure that out in your head?
Yeah.
Very good. Okay? So Ian said this would be n times 4 minus 1, and he would be absolutely correct. Okay? So n equals 1, n equals 2, n equals 3, n equals 4. So I know this is changing by 4, right? So I know there's a 4n, but then 4n, then I have to do something to that 4n to make it into this number. And the thing that I have to do is take away 1, okay? That's an arithmetic sequence. So you'll see some more of this specifically tomorrow, but there's all kinds of different patterns there, okay? Good, Ian. Here's a tricky one, really kind of tricky, but let's try another one. See if you guys could figure out this one. Negative 2, 5, negative 8, 11, negative 14, okay? A sub n is equal to something, okay? So at this point, I'm not giving you a surefire method to do every single one. It's just kind of like practice and see if you can figure it out. So what we did. So what I said is look at this as if it were 2, 5, 8, 11, and 14, right? How much is it changing by? 3, right? Changing by 3 each time. So what that tells you is that there's a 3n in my answer, right? But if this is n equals 1, 2, 3, 4, 5. Then I say, well, 3 times 1 is 3. What do I need to do to 3 to make it into 2? Minus 1. 3 times 2 is 6. What do I need to do to 6 to make it into 5? Take away 1. So it's 3n minus 1. And then the way I make it change signs is by sticking in front of it a sub n, whoops, I'm not recording, okay? Oh, I am recording. And then putting in front of it the negative 1 raised to the n power, right? What if 3, and so here's a kind of a bonus idea. What if I, instead of it starting with negative, what if I wanted this second number to be negative? So what if I want to go negative, positive, negative, positive? Yes?
You put a negative sign in front of the negative 1 to the nth power.
You'll put a negative, oh, that would work. Yeah, you could put a negative sign in front of here. Better yet, you might want to put a negative, you want to do negative 1 to the n plus 1, like that. Because if I plug in 2 in here, right, then that becomes, right, if I plug in 1 in here, I get out 2, and negative 1 to the second power is a positive number, right? So if I want to start with a positive sign, I have to do n plus 1. If I want to start with a negative sign, I just put the n right there. Tricky? Tricky. You like these? Who likes it? It's kind of fun. All right. So are we done yet? Not done yet. Okay? So the sum of a sequence, okay, should take some notes, okay, is called a series. Okay. So if I were, so you should know this word, series. So and sometimes they write this as S sub n, and sometimes they write this as the sum. Have you guys ever seen this symbol? I bet you've seen this symbol. This symbol means sigma, okay? That's a Greek letter sigma, and that means add them all up, okay? So if they say, find S sub 3, find S sub 3 for the sequence 2, negative 4, 6, negative 8, 10. All that means is add up the first 3 terms, okay? What's the sum of the first 3 terms? Tate, what's the sum of the first 3 terms?
4.
That's correct. So you just 2 plus negative 4 plus 6, is that right? Which makes 4. That's it, okay? So S sub 3 is equal to 4. What's S sub 4? What's S sub 4? For the same sequence.
-4?
It would be negative 4. Who said that? Very good, Andy. So like if you know the sum of the first 3, right? You don't have to add them all up, right? All you have to do is go, well, I know the sum of the first 3. So if I want the sum of the first 4, all I do is I add the next term, right? Is that how you did it, Andy? You just added the next number? Yeah, you just add the next number. Okay? And another way to write this is like the fancy math way to write it. You write this as the sum from k equals 1 to 4 of never mind. I'm not going to talk about that yet. Okay? We'll talk about it in a second. Okay? But the sum of the first 4 terms is written like that. Okay? Okay. So getting to the sigma notation. Sigma notation. If I write something like this, k equals 1 to 4 of 2k plus 5. What this means is plug in 1, then plug in 2, then plug in 3, then plug in 4, then add them all up. You should write stuff down. Why are you writing anything down? You two guys. What?
It's hard to get stuff out like that.
Oh, yes?
What is the K equal 100?
K, so this is where you start, okay?
Oh, okay.
So I start by plugging in 1 for K. So this is equivalent to writing 2 times 1 plus 5. So this is your first term, okay? Plus 2 times 2 plus 5. Plus 2 times 3 plus 5 until I get to plus 2 times 4 plus 5. So if I rewrite this out, that's 7, I believe, plus 9, plus 11, plus 13, which gives you 16, 27. Does that make 40? 16, 40. So this is equal to 40. Follow? Okay, so let's try one. Okay, you try. Find, you try. We're almost done, guys. Just about done. Couple more things. You try. Find the sum from K equals 4 to 6 of -1 to the K times 2K. Okay? So what this says is you're going to add up This says 2, overly horrible, right? So the first term you plug in 4. So that gives you -1 raised to the 4th, which is going to be +1, right? So all that 4 does is it makes it positive the first time, 2 times 4, right? So the first term is 8, right? 8? 8. The next term is -1 raised to the 5th times 2 times 5, which gives you -10. And the sixth term is -1 raised to the 6th, which makes it positive, 2 times 6, which is 12. And then you add all those up, and you get 20 minus 10, which makes 10.
Wait, it's really here, isn't it? The odd numbers that make it positive, not the even ones?
No, the odd ones make it negative. Yeah. Yeah, odd ones make it negative because -1 times -1 times -1 times -1 makes 5. Yes, ma'am.
Wasn't it 6 numbers, not 3?
No, because you start at 4. So this says start when K is 4. So you're adding together the 4th term to the 6th term. That's what this means. So you start at K equals 4, and you end at K equals 6. If this were 1, then you would add up the first 6 terms. Okay? This is basically, we're doing like when you do calculus, you do this exact same thing, except you add up infinitely many rectangles or infinitely many numbers and just set of small numbers or a few numbers. So let's see if we could go backwards, okay? 2 where we're going to go backwards, and then you guys are going to work in pairs for a little bit, okay? Right, whoops, am I recording? I am. Right in sigma notation. So here we're going backwards. Right in sigma notation, 1 plus 4 plus 9 plus 16 plus 25 plus 36. Okay, so what you want to do is write this as the sum from K equals 1 to something up here of some formula. Okay, so that should be pretty easy. How many terms are there? 6. So what goes up here? 6. 6 goes up here. What's the pattern? What am I doing to those numbers each time? Middle? What's special about these numbers? No one knows what's special about these numbers. What? They're square numbers, right? So 1 squared is 1, 2 squared is 2, 3 squared is 9, 4 squared. So it's just k squared, right? That's all. Okay? Not super hard. All right. Let's do one more, okay? And then you guys could have some time to try to do this. K equals, whoops, new page, okay? Write in sigma notation. 2/3 plus 3/4. I'm just going to do this one here. 4/5 plus 5/6. So I want you to go backwards, okay? If I call this 1, okay? So, anyone see a way? So you're going to have 2 k's in this one. So, how is this number related to k on the top? If this is k equals or n equals 1, 2, 3, 4, how is the number on top related to the number of the term? Calvin?
It goes up by 1 each time.
It's 1 bigger, right? But it's also it goes up by 1, but it's also 1 bigger. So I could write the top part of the fraction as k plus 1, right? What could I write the bottom of the fraction as? Jessica? K plus 2, right? Because this number is 2 bigger than k, right, on the bottom, and this number is 1 bigger than k. How many terms are there altogether? 4. And does that make sense? Check it if it doesn't, right? If I plug in 4 in here, do I get 5/6? Yes, okay? So that's how you kind of do it, all right?